So the main objective on this first page is to figure out, using words, how you would explain to the customer that you're going to calculate their price. And so you notice that they have notebooks and that they have pencils, and they're wondering how you're not going to mischarge them given that the register is not working. So what you would probably say to the customer is that first you would count the notebooks, and then whatever that number happened to be, you would multiply that by the cost of a notebook. And then you would do the same thing with the pencils. You would count the pencils, so find the number of pencils, and then multiply that by the cost of a pencil. And you would add the two together. So that's what that's looking for, a verbal description of how you would achieve that. So we're working on our communication right now. So now we're actually going to calculate this out. So on the previous page, we decided that we needed to know the number of notebooks times the cost of one notebook. And then we needed to know the number of pencils times the cost of one pencil. And that we would add these two things together when we were done. So once you see that, you see a couple of important pieces of information. One is that there's 25 items total. 1 dozen of them are pencils. So what that's going to mean to me is that there's 12 pencils, because remember that there are 12 in 1 dozen. And we had also gone through the store to find out that pencils are 50 cents each. So I'm going to multiply 12 by 50 cents. And I figured out that notebooks were $1.25. So that's my cost of a notebook. And the way in which I find the number of notebooks is, since they have 25 items total and 12 of them are pencils, then what I would need to do is I would need to do the total items, 25 minus 12. Now you might be thinking, well, I just put 13 here. And that's 100% accurate, because 25 minus 12 is 13. But the way in which your brain found that number was it did subtraction. It did 25 minus 12. And actually, if I was color coding, it would be red, because that was my number of pencils. So now I've got 13 notebooks times $1.25 plus 12 pencils times 50 cents. And so if I calculate this out, that's going to come out to $16.25 for the notebooks plus $6 for the pencils, and that would be a total of $22.25. So kind of the key takeaway here that we're going to be focusing our attention on is this idea that we're only going to be working with one kind of number, and we're going to be subtracting to find the other number. So on part B here, after you've completed all of part A 1 through 7, what we're looking for again in words is, in each case, how did we find the total cost? And so like for the cost for the shirts, we would have done 5 times 15, and the donuts would have been 12 times 65 cents, so on and so forth. And so the way in which we did it, it was the number of items times the cost per item. That's what we're looking for using words. And so now we're going to use this general rule to write an expression for the total cost for each of these situations. And the difference here is that we're being told maybe the cost of the item, but we're not being told the number of items. So unlike above, where I actually could find the total cost because I had the two numbers that I needed to multiply, this time I can't actually find the cost, but what I can do is I can come up with an expression. So for example, for the beads, it would be 0.07 R. And so this is telling me that I can't calculate my cost until I know the number of red beads, but once I know it, I would multiply it by 7 cents. So go through and complete the rest of these for part C 1 through 5. And there was a number 6 as well up on the next page if it happened to go there. Okay, so we've investigated multiplying number of items times their cost to find the total cost of something. Now we're going to focus on the leftover part of it. So this time it says that we're making a necklace using both red beads and blue beads, and we need to use 50 beads in all. So that 50 beads in all is going to be the red beads, however many there are, plus the blue beads, however many of those there are, and we don't know either of those numbers. It does tell us that we don't know the number of red beads, but we're going to use R to represent that thing. And so in this space over here, I could kind of think of this as an R. So I need my total to be 50. So I could think of this in two ways. I could think of it as R plus something that equals 50, or I could discover that in order to find this missing number, now you might be thinking, well, let me just put a B there for blue beads, for the number of blue beads, which makes total sense. But what we're going to want to do is we want to stay with this one variable. So for right now on this line, we want to write an expression that has one variable. And so the way that I would find this missing number is I would take my total, which is my 50, and I would subtract the number that I've already used for red, and this would be my leftover that would give me blue. Notice it also does not have an equal sign because it's not an equation, it's going to be an expression. Let's do one more of these. So on the next one, it says that I've got 7 strips of fabric to make one curtain, and I'm making that curtain using solid and patterned. And so that means my solid and my patterned together need to total to 7. And the variable that they're giving me in this case, they're telling me S for the number of solid strips. So if I've already allocated or used S of the 7 for solid, the way in which I would find the pattern is I would do 7 minus S. Because if you think about it, let's say there was 1 solid, then my brain knows there would be 6 left over for the pattern, and I get that by doing 7 minus 1. If there were 4 solid, my brain knows there would be 3 left over for the pattern, and I would get that by doing 7 minus 3 or 4. I forget what I just said there. But we're doing it by subtracting our total. So what I want you to do at this point, if you haven't gotten to these parts yet independently, I want you to try examples 3, 4, and 5 to come up with your own expression. And then pause the video as you're doing that and press play when you're ready to check your answers. So on number 3, we have a total of 75 coins, and 2 things are making up that total, the number of nickels and the number of quarters, and it assigns the variable for us, N for nickels. So again, it would just be easy to say, well, let me use Q for quarters, but we're trying to avoid that. We're working with one variable. So the way I would find the number of quarters is I would do the total minus the number of nickels, so 75 minus N. On number 4, I'm collecting soda cans and water bottles. I have a total of 150, and X of those are soda cans. And so the way in which I would find my water bottles is I would take my total and subtract the number of soda cans, which is X. And then the last one, 250 students in our class, G of which are girls. I would do my total students minus the number of girls in order to find the number of boys. So I'll do number 6. It's scaffolded into 5 separate parts. And you can use these 5 separate parts to model after once you get to 8, 9, and 10 that are not scaffolded in this way to help you set up your examples. After number 6, try your best on 7 through 10, and we'll discuss any more after that together, probably next week in lab. So it tells us that we have 2 part-time jobs, and one of those jobs is running errands, and we make $6 per hour running errands, and we also walk dogs, and we make $5 per hour walking dogs, and we can work a total of 10 hours this week. So the first thing that's important to recognize is that we are just talking about this week. We're not talking about multiple weeks. So first we want to explain in words how we would find the total amount of money that we would make this week. And so what I would need to do is I would need to know the number of hours that I spend running errands, and I could multiply that by 6 because I know that it's $6 per hour. I would need to know the number of hours I spend walking dogs, and I can multiply that by 5 because that's how much I make walking dogs, and then I would add those 2 amounts together. So in this case, I've got some information that I know, like how much I make per hour at each job, and then some information that I don't know. So we're going to go for a deeper dive on that. So the next thing that I notice is that they assign me a variable, which is the variable R for running errands. And so that's pretty simple. It can take this space right here. So rather than using all these words, I can do $6 per hour times our number of hours running errands. So this is the expression I would use to find my money that I make from running errands. So if it was maybe 7 hours running errands times 6, I would get $42. Now I'm going to write an expression to represent the total number of hours. So that's kind of a key here. It's the number of hours, not the amount of money, that I would spend walking dogs if I've already spent R of those hours running errands. So it's important to remember that I can have a total, I meant to do that in green, a total of 10 hours. And R of them are already running errands. So that means that the way that I would find the hours left to walk dogs would be 10 minus R. And so this is the expression that represents this number right here, walking dogs. So we could use another variable, but we're not going to use another variable right now. We're only going to work within the variable that they gave us. And so if there were 2 hours running errands, my brain knows that it would be 8 left for walking dogs. If it was 7 hours running errands, my brain knows that it would be 3 hours left for walking dogs. Or 4 hours running errands, my brain knows that it would be 6 left for walking dogs. So the way that I'm getting those leftovers is I'm doing subtraction. And so now I can take this information and slide it in right here. And so the way that I would find the amount of money, I would do 5, because that's how much per hour, times 10 minus R. So this one was a little simpler. Running errands is just 6 times R. And on the walking dogs, I have the price per hour times the number of hours. The difference is that the number of hours is a math expression. It's not just a straight up variable. And so now I'm going to do what I set up here, which is I'm going to create this equation, but with these pieces of information. And so my total amount of money is going to be the money that I get from running errands added to the money that I get from walking dogs. And then I'm going to simplify that. And so the way that I would simplify that is I would distribute. So I'd get T equals 6R plus 50 minus 5R. And then I would combine like terms if possible, which I can combine 6R and negative 5R. And so that means my total money that I'm going to earn would be 50 plus 1R, which might look a little funny because you're thinking, well, where did the 50 and the 1 come from? They weren't really mentioned in the problem, but we're definitely going to talk about that next week. So at this point, I want you to focus on 7 is also, oh no, 7's not scaffolded either. So if you're having trouble coming up with this simplified equation right here, I want you to follow all of these steps for the next few problems as well.